Okay, today we are going to be learning about kites. Kites are again a quadrilateral, so a four-sided figure with two pairs of consecutive sides congruent. So in our diagram, right, the two consecutive sides would be Ki and Ke, right? Consecutive just means right next to it. We also have It congruent to Te, right? So It equals Te, therefore we have this lovely thing called a kite. We have some specific properties of a kite, and again, we're starting with a blank slate here. So the only thing we know is that all of the angles will add to 360. And then these additional properties. It is not a parallelogram. It is not a trapezoid. This is a new type of figure called a kite. In a kite, diagonals are perpendicular. So we will have a right angle in each of these corners. So maybe Pythagorean theorem is triggering in your head right now. Our next thing is that one diagonal is the perpendicular bisector of the other diagonal. So in this case, we will have that I to this center point to E will be congruent because KT is the perpendicular bisector of IE. Okay, so KT is doing the splitting, is the perpendicular bisector of IE. And typically you can look at the kite and see which are those two congruent parts, which measures look the same, right? K to here does not look like the same as from here to T. So you can use your common sense, looking and measuring with your eyes, what two parts will be congruent in the kite. In addition to that, our next property is that one pair of opposite angles are congruent. And these are called the non-vertex angles. They're created by two different tick marks. So the two non-vertex angles are angle I and angle E. So all of angle I is congruent to all of angle E. So again, they're created by two different tick marks. We have one tick mark here, two tick marks here. One tick mark here, two tick marks here. Therefore, the angles that created by those two lines will be congruent. We cannot conclude that angle K will be congruent to angle T. That will make this an entirely different figure. But what we can say is that they are vertex angles, so angle K and angle T are the vertex angles, and they are bisected by one of the diagonals, meaning split in half. So this measure, right, will be congruent to this measure. Angle T will be congruent, part of angle T will be congruent to that other part of angle T. Okay, let's give this practice a shot using these properties. So here we're given that W, X, Y, Z is a kite. We want to find the lengths of the sides. So in this case, we know that, or we can kind of conclude that WY is the perpendicular bisector. So, therefore, this is congruent to this. So that will have also a measure. Okay, so the other thing that we know about our diagonals is that, right, if we look at number 1, the diagonals are perpendicular. So we can put a right angle in each of these corners. And again, like I mentioned before, Pythagorean theorem should be triggering in your head. We are trying to find, first, the measure of W to X. So we're trying to find the measure of this. If I'm zoning in on just a portion of this figure, more specifically this figure here, right? We have a three-sided figure. It's a triangle. with a right angle in the corner, making it a right triangle. I'm going to label WX as, well, X, because we want to have a variable. To find this measure, we need to use the Pythagorean theorem. Remember that hypotenuse squared is equal to leg squared plus leg squared? So to find that measure, we'll just do x squared is equal to 24 squared plus 10 squared. And then, guys, we're continuing to solve this like we typically would. So we would take x squared, which we can't simplify any further, and then simplify the 24 to 576, add that to 100, continue to solve and simplify, and we get x is equal to 26. So x is now 26. Now in a kite, we know that we'll have two pairs of consecutive sides congruent. So if we know WX is 26, this measure will also be 26. Mostly because we have the same leg measures, right, creating that other right triangle on the bottom. So we can also conclude that W to Z is 26. We'll do the same thing to find the measure of W or XY. XY, I'm just highlighting that in purple so we can see it more clearly. Right, again, we have a right triangle on this. So we're using Pythagorean theorem. Right, leg squared plus leg squared equals hypotenuse squared. In this case, the hypotenuse, well, in all cases, hypotenuse is directly across from a 90-degree angle, which we don't know. I'm just going to label this as y to use a different variable. Right, so y squared is equal to leg squared plus leg squared. We continue to solve and simplify. We get 100 plus 100. Y squared is equal to 200. When we take the square root of 200, let me put this in my calculator. Square root of 200, we will get 14.14. And writing it to two decimal places would be great. So 14.14. We also know that YZ is created with the two same measures of legs, right? 10 and 10. So therefore YZ is 14.14. Okay. The other thing that I want to talk about is the properties of the angles within a kite. So with our angles in the kite, we want to identify our vertex angles and our non-vertex angles. So our vertex angles are created by two congruent tick marks. So this would be a vertex angle and this would be a vertex angle. So in that situation, we know that vertex angles are bisected, right? We know more specifically that the non-vertex angles are the congruent ones. So this angle will be congruent to this angle. Again, they're created by two different tick marks. So we can conclude that angle G also has a measure of 92 degrees. We do not know that non-vertex angles are congruent. More specifically, they won't. So my suggestion when you're trying to figure out the measure of a non-vertex angle is think about just our property of a quadrilateral. We know that all the angles have to add to 360 degrees. So we will create an equation, x plus 92 plus 92 plus 60 is equal to 360. We'll continue to solve and simplify that, so add 92 plus 92 plus 60, 92 plus 92 plus 60, and we'll get 244. Set it equal to 360, and we'll get a measure of 116. So the measure of angle X must be 116. And of course, if you're more comfortable without setting up an equation, just adding J, G, K, and subtracting that from 360, that's fine with me. Again, I like to just set up equations. Okay, and then number 3, deals with, again, more angle properties of a kite. This one is probably one of the trickiest ones, but still very, very doable. So here we want to, again, identify the difference between our vertex angles and our non-vertex angles. We know GM and EG will be the same measure, just because they look like they will be. And again, on a test or quiz, those segments will be marked. So in this case, our vertex angles are angle G, and there should be an O. Angle O and angle G, right, are our vertex angles. Our vertex angles are the ones that are bisected. So we know each of these parts are congruent. Cool. So with that information, we can also conclude what the measure of the angle W is. Angle W, right, is that one bisected angle. So W is 37. To find the measure of angle Y, it's a little bit more simple than you might think. We know, right, based off of our properties, is that the diagonals are perpendicular. So within this kite, we can put a 90-degree angle on each of these. And then just focus in on one of these triangles, like we would with the Pythagorean theorem, but now we're dealing with angles. We know that this 90-degree angle plus the 37 plus the Y must add to 180 degrees, right? 90 plus 37, and that'll be whatever Y is equal to. So 90 plus 37, I'll take that away from 80, and we'll get a measure of 53 degrees for Y. Okay. We also know in a kite that while these vertex, non-vertex angles are not bisected, we know this top angle is congruent to this top angle. We know the bottom angle is congruent to this bottom angle. So therefore, we can also copy that this measure would be 32 degrees. If that's the case, we can again zone in on this top triangle, right? Angle, 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 right? All of those angles must add to 180 degrees. So 32 plus x plus 90 equals 180. We combine those like terms, and we get x is equal to 57. Now, for the rest of this note sheet, I want you to try number 4 and number 5. I will put down the congruent marks, right, with the angles to help you out. But again, I want you to try this on your own to see if you do indeed understand exactly what the kite properties are. From that, make sure you check it off with me once you try 4 and 5. And then you also have a little quick review dealing with all of our properties of all different types of quadrilaterals. So I've taken a few minutes to put down the congruent marks within the kite. So take a look at this. Also copy down those congruent marks, set up some type of equation. You also want to figure out what those diagonals do to each other, right? Go back to your properties and see what else you need to add into the diagram. That's specifically for number 4. For number 5, my clue here is to set up an equation to deal with first this triangle. Find and solve for x, and then plug that back in. So that is my one suggestion for you. All right, best of luck. All right, again, check this off with myself, and then once I check that off, you'll try 6, 7, and also 8. All right.